Have you ever stood in front of your microwave, door closed, nothing inside, and wondered, what would happen if I just pressed start? I mean, we've all accidentally run it empty for a few seconds, right? But what if you let it go for a full minute or longer? Today, we're answering one of those questions you've probably had at 2 a.m., but never actually tested. And honestly, you shouldn't test this one at home. What really happens when you microwave nothing, and trust me, the answer is way more dramatic than you might think. I'm about to show you why this simple experiment could literally destroy your microwave, the surprising physics that makes it happen, and some myths that need to be busted. So stick around, because things are about to get electric, literally. But first, if you love this kind of mind-bending science content, hit that subscribe button and ring the bell so you never miss an episode. Let's dive in. Okay, before we nuke the nothing, we need to understand what your microwave is actually doing when it's working properly. And no, it's not just magic heat waves, though it kind of feels that way. Inside your microwave, there's a component called a magnetron. This thing is basically a tiny radio station that produces electromagnetic waves at a specific frequency, about 2.45 gigahertz. These waves bounce around inside that metal box and do something really specific. They make water molecules vibrate. Here's the cool part. Water molecules have a positive end and a negative end, kind of like tiny magnets. When microwaves hit them, these molecules try to align with the electromagnetic field. But the field is switching back and forth billions of times per second. So the water molecules are basically doing this frantic dance, spinning and bumping into each other. All that movement creates friction, and friction creates heat. That's how your food gets hot. So your microwave doesn't actually produce heat directly. It produces waves that make the water in your food produce heat. Clever, right? Now, here's where things get interesting. If you're curious about exploring more experiments like this, and trust me, there are way safer ones you can actually try, check the description below to download our free ebook with 50 DIY science experiments and fascinating science facts. It's packed with mind-blowing experiments you can safely do at home, plus explanations that'll make you sound like a genius at parties. Seriously, grab it while you're thinking about it. So now we know microwaves work by exciting water molecules. But what happens when there are no water molecules? What happens when you microwave nothing? This is where things get sketchy. When you press start on an empty microwave, the magnetron still fires up and starts blasting those electromagnetic waves. But now there's nothing to absorb them. No food, no water, no molecules to dance around and convert that energy into heat. So where does all that energy go? Well, it's got to go somewhere. Energy doesn't just disappear. This is where the laws of physics start causing problems for your kitchen appliance. Those microwaves start bouncing around inside the chamber with nowhere to go and nothing to do. Some of them get reabsorbed by the magnetron itself, and this is bad news. Really bad news. The magnetron wasn't designed to absorb its own energy. It's like screaming into a megaphone that's pointed back at your own face. Not a great idea. As the magnetron absorbs its own radiation, it starts to overheat. We're talking serious heat buildup. The components start to degrade. The metal can warp. And if you let it run long enough, you can permanently damage or completely destroy the magnetron. But wait, there's more. And this is where it gets visually dramatic. In some cases, running an empty microwave doesn't just overheat the magnetron. It can actually create sparks and arcing inside the chamber. You won't believe what happens next. Here's why. If there are any imperfections in the metal walls, any tiny food particles stuck to the sides, or even the metal rack sitting there by itself, those concentrated microwaves can cause electrical arcing. You might see bright flashes of light, hear crackling sounds, and witness what looks like miniature lightning shows inside your microwave. This happens because the electromagnetic energy builds up so intensely in certain spots that it ionizes the air molecules, creating plasma. Yes, actual plasma, the fourth state of matter, the same stuff that stars are made of, right there in your kitchen. Pretty wild, right? But before you think that sounds cool and want to see it, remember, this plasma is also melting and damaging the interior of your microwave. Those scorch marks you might see, that's metal being vaporized. The protective coating on the walls can burn away, exposing bare metal that will rust and create even more problems down the line. And in extreme cases, if you really let it run, the magnetron can fail catastrophically, sometimes with a loud pop or bang. At that point, your microwave is basically an expensive paperweight. The damage isn't always immediate, though. Sometimes running an empty microwave for just a few seconds won't cause obvious problems right away, but you're shortening its lifespan with every empty run. Kind of like how revving a car engine with no oil might not blow it up instantly, but you're definitely not doing it any favors. Okay, so let's bust some myths, because there's a lot of misinformation floating around about this topic. Myth number 1, microwaving nothing will cause it to explode. Not exactly. While a magnetron can fail dramatically, your microwave isn't going to detonate like a bomb. Modern microwaves have safety features and thermal cutoffs designed to shut down if things get too hot. That said, it can still break in expensive and sometimes scary ways, so don't test this theory. Myth number 2, running a microwave empty will create dangerous radiation leaks. Nope, the metal box is specifically designed to contain those microwaves whether there's food inside or not. The waves don't become more dangerous or suddenly escape just because the microwave is empty. The danger is to the appliance itself, not to you standing nearby. As long as the door seals are intact, you're fine. Myth number 3, you can run a microwave empty if you put a glass of water in it. Well, yes and no. This one's actually partially true. If you put a microwave-safe container with water in it, you're giving those waves something to absorb into, which protects the magnetron. But here's the thing. That's not microwaving nothing anymore. That's microwaving water. So this is really just a workaround to the original question. And here's a fun fact while we're busting myths. Different microwaves handle being run empty slightly differently. Some older models are more vulnerable to immediate damage, while newer ones might have better protection circuits. But none of them are designed to operate empty, and none of the manufacturers recommend it. Let's get a bit deeper into the physics of why this is such a problem, because it really comes down to energy balance. When a microwave operates normally, the energy flows like this. Electrical energy from your wall powers the magnetron, which converts it to microwave radiation, which gets absorbed by your food and converts to heat. That heat then dissipates into the air when you open the door or gets carried away by the ventilation system. It's a nice, clean energy flow. But when you run it empty, the flow breaks down. The magnetron still converts electrical energy to microwave radiation, but now that radiation has nowhere to go. It bounces around, reflects back, and some of it gets reabsorbed by the very device that created it. This creates what engineers call a standing wave pattern. Instead of the energy being distributed evenly and absorbed, it concentrates in certain spots. Those hot spots can reach incredibly high energy densities, which is what causes the arcing and the overheating. Think of it like this. Imagine filling a balloon with water from a hose. The balloon expands, and the water has somewhere to go. That's normal microwave operation. Now imagine sealing the end of the hose and turning on the water. The pressure builds up with nowhere to escape. Eventually, something has to give. That's your empty microwave. The magnetron has a limited capacity to handle reflected energy. When you exceed that capacity, components fail. Sometimes it's a thermal failure, where things literally melt. Sometimes it's an electrical failure, where insulation breaks down and you get short circuits. Either way, your microwave is toast. Or rather, it can't make toast anymore because it's broken. Now, I know some of you are thinking, okay, but what if I want to experiment safely? What can I test with my microwave? Great question, and this is where I want to emphasize. Never deliberately run your microwave empty, even for science. It's one of those things where the risk outweighs the educational value, especially when we already know what happens. But there are tons of safe microwave experiments you can do. You can watch grapes create plasma, which is actually a recommended science experiment because the grapes absorb enough energy to protect the magnetron while still creating that cool plasma effect. You can make microwave s'mores, test which materials are microwave safe, or even measure the speed of light using chocolate bars and some math. Speaking of experiments, if you haven't already, seriously go download that ebook from the description. It's got 50 experiments that are actually designed to be done safely, with proper precautions and explanations of the science behind each one. You'll learn way more trying those than you would killing your microwave. Here are some general microwave safety tips. Always have something microwave safe inside when you run it. If you're just testing to see if it works, put a cup of water in there. Never put metal objects inside unless they're specifically designed for microwave use, like some microwave-safe racks. Don't superheat water, because it can explosively boil over when you disturb it. And keep it clean, because food buildup can cause arcing even during normal use. The bottom line is this: your microwave is a precision appliance that's designed to operate within specific parameters. Treat it right, and it'll heat your leftovers for years. Abuse it, and you're shopping for a new one. Before we wrap up, let me hit you with some microwave trivia that'll make you appreciate this invention even more. Did you know that the microwave oven was invented completely by accident? In 1945, an engineer named Percy Spencer was working with radar equipment when he noticed the chocolate bar in his pocket had melted. He realized the magnetron he was testing was cooking the chocolate with electromagnetic waves. And boom, the microwave oven was born. Here's another one. Microwaves heat food unevenly, which is why your leftovers always have cold spots. This happens because the waves create those standing patterns we talked about earlier, with hot spots and cold spots throughout the chamber. That's why turntables were invented, to rotate food through different zones and even out the heating. And get this, the frequency that microwaves operate at, 2.45 gigahertz, was specifically chosen because it's absorbed well by water but doesn't interfere with radar and communication systems. It's basically a Goldilocks frequency that's just right for cooking. Oh, and one more, you can actually estimate the speed of light using your microwave, a ruler, and some chocolate. The distance between melted spots in chocolate corresponds to half the wavelength of the microwaves. Multiply that by the frequency, and you get the speed of light. How cool is that? So, what really happens when you microwave nothing? Your magnetron becomes a self-destructive machine, potentially creating plasma light shows, damaging internal components, and eventually breaking down completely. It's a fascinating demonstration of energy physics gone wrong, but it's definitely not something you want to try at home. The takeaway here is simple. Microwaves are brilliant pieces of engineering designed to convert electromagnetic energy into heat by exciting water molecules. Take away those molecules, and you've broken the system. The energy has to go somewhere, and unfortunately, it goes into destroying your appliance. But isn't it amazing how much science is hiding in these everyday devices we take for granted? That box sitting on your counter contains the same technology that powers radar systems and satellite communications. It creates electromagnetic fields strong enough to make molecules dance billions of times per second, and it does it all safely and reliably as long as you use it the way it was designed. If this video made you see your microwave in a whole new light, do me a favor. Smash that like button, subscribe if you haven't already, and hit the notification bell so you catch our next deep dive into everyday science. Drop a comment below telling me what common household item you want me to explain next. Toaster, refrigerator, Wi-Fi, router, let me know. And remember, if you want to keep exploring science in safe and mind-blowing ways, that ebook in the description is waiting for you. 50 experiments, tons of facts, 0 destroyed microwaves. Thanks for watching, stay curious, and I'll see you in the next one. And please, for the love of physics, put something in your microwave before you turn it on.